Hey everybody, my name is Shane Hooley, and I'm going to be giving you a presentation on the drone compasses and the effect of electromagnetic interference on those compasses. So for the past few summers, I've worked at Duke Marine Lab in their Marine Robotics and Remote Sensing Lab, or MARS as we like to call it. So we're going to go over what the drone compass is and how it works, as well as the drone parts that cause interference on that compass, and then how can we reduce that interference. And that's actually the drone, we call it the Mars rover, that I worked on for 2 summers now. We used it for sea turtle and light pollution research. So the drone compass, it utilizes a magnometer, which in all intents and purposes is a Hall effect sensor. And what that does is it utilizes Lorentz forces to measure the deflection of electrons across a plate, and then it measures the voltage that is caused by that. And essentially there's 3 axes on the compass, which you can see here, where it can measure, measure the Earth's magnetic fields to kind of tell which direction it's oriented. Now, some drone parts that cause this magnetic interference that we're trying to stay away from would be the DC motors, because DC motors operate on magnetic fields that cause torque. And then electronic speed controllers, you can see right here. And what that basically does is it controls the DC motors. And to do so, it uses a lot of current, which from Ampere's law, we know current through a long wire creates a magnetic field. And these aren't necessarily shielded wires. I think it's just silicone for water resistance because it's a waterproof ESC. And then we also have power wires, you see right here, which are about a 16 gauge wire, and that powers the entire drone. So there's a lot of current moving through those as well, which causes a magnetic field. So to reduce this interference, what we would do is we would move the sensor away from the source of interference. So you can actually see right here in the waterproof housing that the compass is elevated away from all these wires, as well as the autopilot, the telemetry link, and then the radio frequency receiver. And then another way to do it is to actually twist the wires, as you can kind of see all along here, all these twisted wires. What it does is it puts those wires super close together, and because current traveling in opposite directions through a wire is going to help cancel out, the closer they are, the more effective that canceling out of magnetic fields. Now, to recap, we have the drone compass, which is a Hall effect sensor that utilizes Lorentz forces, as well as the drone parts that cause interference, such as ESCs, motors, and power wires. And then to reduce that interference, what we want to do is we want to separate the compass and twist the wires. And you actually see here 2 drones I've worked on. There's the rover actually out in the field on Shackelford Banks, and then we have a boat here that I've been working on for the past summer. Thank you.